All right, welcome back everybody to day two. Thank you all for showing up. We do have a much smaller group than we had on Monday. And you guys are going to see that as we progress through this course. As I mentioned before, throughout Monday, um, you're not required to have to go through the entirety of this course to be eligible to apply to any of our courses, right? Uh, if you really wanted to, and you can be completely self-taught for however long you want to be self-taught, and then just apply all the way through without having to take any of our introductory courses. One of the unique things about Platoon is that we offer these courses to you guys to make the journey a lot easier, right? For those of you who have been self-taught, you've probably already gone through the headache of wondering, like, what do I need to know to start my journey in tech? Like, I don't know where to start, right? I believe I mentioned it on Monday, was that when I first started with my journey down tech, I didn't know what coding languages were for what, right? So I went to my public library, um, and I signed out like 7 different coding books, which was like the limit of how many books I can take out, in like all different kinds of languages, because I just didn't know where to start, what I needed, uh, what language was for what frameworks I needed to learn. Platoon helps, it helps streamline this process for you guys to make it easier for you, right? So you don't have to make it all the way through the course. It's recommended to ensure you get everything that you need to be successful. Um, but yeah, as I mentioned, you might see our attendance kind of go down, and that's okay. Stuff happens, life happens, we get busy, but you're not forced to be here throughout the entirety of the course. You can still apply if you wanted to, right? But without further ado, let's go ahead and continue. We'll pick up from where we left off yesterday. Sorry, not yesterday. Monday. So Monday, unfortunately, due to the limited time that we had, we weren't able to get all the way through lesson 1. I hastily told you guys about the exercises after the lesson, and I fully acknowledge that it might have been a little confusing if it is the first time we've ever seen VS Code or ran any kind of code. So we're going to talk about running the exercises from lesson 1, and how to work on them on your own if you don't want to use Jupyter notebooks. So let me go ahead and share my screen. And as I do this, I do want to apologize ahead of time. I do have a 3-year-old, and he tends to have an attitude. So if you hear him in the background, I'm sincerely sorry. Let me know if it gets too loud or it becomes a disturbance. But here we are. We are currently in our code spaces. Everyone should be seeing, I believe this is lesson 1 of our curriculum. Is that correct? Can I get some head nods? Right on. Okay. So the first thing that we want to make sure is working or set up is going to be our kernel, right? So I mentioned it yesterday or Monday, what the kernel is. So essentially, a kernel is almost like an interpreter. It's a way that your computer is able to read what language you're typing in, right? So it doesn't just magically learn like or know like, hey, you wanted to talk to me using Python or JavaScript or whatever form of way that you want to communicate. It needs a way to kind of, the best way I can explain it in human terms is kind of just something to interpret the language, right? And that's what we call the kernel. Well, when we install the extensions for Jupyter Notebook and Python, we install Python 3.12.1, right? So if this says select the kernel, that's probably because you haven't applied the Python kernel yet. But you see here, when I click it, it lets me change my kernel. So if you had other different kernels, which it's out of the scope of this class, you can select them here. The only one you need is Python 3.12.1, which is the Python version we installed. So as long as you have this selected, you should be able to run your code. Now here's probably some confusion that you might have encountered, right? This curriculum is written in Jupyter notebooks, right? Why did we choose this framework to provider curriculum. I'm not quite sure. I wasn't the one who initially wrote the first draft of this curriculum, but they wrote it in Jupyter Notebooks. I can make an educated guess that it's because it's very friendly to visualize, right? If you had like raw like text, it wouldn't be as visually appealing to somebody who's never seen code, and it may be difficult to read, right? Jupyter Notebooks allows us to, write text in here with some form of formatting, so it looks visually appealing and easy for the eyes for you, taking the information, and at the same time also write raw code, right? And we do that in the forms of what we call cells, right? And we have two different cells. We have markdown cells, which you see right here, and we have code cells. For some reason, this cell is a markdown cell. I do not know why. This should have been a code cell, right? So when you come here and you try to run this, you might not be able to run it. So I do apologize for that. What you can probably do here is, hold on, give me a second. Let me try to write some code. Yeah, so you see here, when I tried to add some Python code, it's just raw text. And it might have been very confusing if you try doing this on your own and you ran it. It's like, why is it not doing nothing? Um, well, for some reason, it's reading as plain text, which it shouldn't. So let me go ahead and see if I can change it back and forth. So notice that I changed it to a markdown cell, and then I'm gonna change it back to a code cell. And now, for some reason, now it's working. Jupyter Notebooks can be very weird. Notice that on the very bottom it says Python now. Um, Okay, here we go. I can probably select this right here, plain text, select cell language mode, and I can select Python, and now it's able to read it. For some reason, it didn't load it properly. This is actually the first time this happens. Um, it didn't happen last class. Maybe like an update with Jupyter Notebooks that I'm unaware of. But yeah, there's some weird stuff going on with the cells when you load it up. So you might have to do a little messing around with this. Just know that you can select whatever language it's talking in by clicking the bottom right and then selecting Python, or what you can do is click on the three dots here for more actions, switch it to Markdown, and then click that area again, and switch it back to a cell block, right? Um, so either one works. I do apologize for this issue. This is the first time I encountered it here in Jupyter Notebooks, so I was not aware of this until after class. But hopefully that answers your question, Norma, on how to run the code here, right? What you're going to see here for all these exercises is going to start very similar to this, where you're going to have the type of section that this exercise is going to be about, like for example, Python syntax basics. So the next following exercises will be all in regards to syntax basics, right? You have the different exercises with a brief description, like write a Python script that prints the following. Well, if you're new to code, you might be a little confused with what script means. Script is just a fancy word for instructions, right? Write some instructions, some code instructions that does the following. That's all really what a script is. So we want to write a set of instructions that prints the following: hello Python world. The print statement should have been covered on lesson 0, which is a pre-course, which I talked about, some of the requirements that you needed to do before we started the course. I understand some people did not attend the info session, so hopefully you guys were able to check out the pre-course throughout these last 2 days. If you're wondering about how we print stuff onto our screen, essentially print is just a method that we use to visually see what our code is doing, right? It's very helpful during debugging sessions when you have a bunch of code and you're trying to figure out why your code's not working. The print statement allows you to print something like the name suggests. Print something into your screen that you can visually see to know what your code is doing. So here we call the command print, and it needs to print this message right here, which is hello Python world. So we have to kind of adjust this code to show exactly how this should look like. I noticed that this only tells you expected output, and the expected output is literally verbatim, hello Python world. So uh, you, as an adult, you need to be able to see this like, okay, it's doing what it should be doing, right? There's no tests here that you can run that's going to tell you, hey, this is correct, or hey, this is wrong. This is just you visually seeing, okay, it's doing what I expected it to be doing, right? And that's how the rest of the exercises are going to be kind of broken up into. So hopefully that answers any kind of questions that you guys might have had. Now, let's say uh, you really dislike Jupyter notebooks. Like, hey, Roger, this is too confusing. I don't like the fact that I have to keep switching between cell blocks to Markdown, or I have to keep selecting um, what cell language is working on. That's fine. What you can do is just create a different file, right? So you can navigate, right? If you press these two, paper icons right here, which is your Explorer, well, it'll open up your folder directory. And here you can create a new folder specifically for all your exercises, or just create one big file, right? Whatever works for you. So I'm going to go ahead and select the outside of this box so I can highlight everything. And I'm going to create a new file. And I'll just call this like homework.py, right? Homework.py. It'll be a raw Python file where I can come here and, do the work and then run it on my terminal to see if it's doing what it should be doing. So I'll come here, say write a Python script that prints the following, which is literally this. So I will come back here and I will say print hello Python world. I think that's what it was. Is that correct? Yeah. I do the extracts here and then I just run it by pressing the play button on the top right. And then here I see that it's doing what it should be doing. So if you don't like Jupyter Notebooks, if it's giving you too much of a confusion, this is one of the reasons why I like CodeSpace. You can just open up a raw Python file and just do it here, right? So either one will work. Uh, if not, if you're still not comfortable with VS Code, you don't have to use CodeSpaces. If you have some other form of software, if you are still using Replit and you, for whatever reason, you have like, I know some people have bought the Replit stuff, or you have your own other free software that you might have seen out there on the web. That's fine, right? You have an editor that can do it there. It doesn't have to be done here. As I mentioned before, this isn't being graded. This is just the curriculum here on Digits for you guys. And then where you do it, it's up to you. As long as you have somewhere to write the code and see the output, that's all that matters, right? Sound good, guys? All right. Let's go ahead and move forward. So that takes care of the homework. Let me take a slight tactical pause and review the chat. Andrew asks, do we need to download Jupyter Notebooks? You do not need to download Jupyter Notebooks. When you set up your code space, which was covered on day one, you can review the video on our Slack channel. There's a link for that. We talk about how we set up the code spaces. It's going to install a Jupyter extension, right, in your code space. If you want to know how that's done, visit the video. It'll show you how to do it. But the extension is all you need. Mark asked, can you send the attendance form one more time? Absolutely. It is in the Slack channel right here. I'm going to copy and paste it to make it easy. And then I'm going to send it in the chat. There it is. So, all right, right on. Okay. Cool stuff. I think that handles everything in the chat. Let's go ahead and move forward. So let me go ahead and close up my Python file and the lesson one exercise. And we're going to continue from where we left off, which is the methods, right? So I believe we talked about upper and lower. We're going to kind of breeze through these, right? I did kind of give this to you guys as like your own homework outside of class. So we'll kind of go through these real quickly and just talk about them briefly. A lot of these methods that are here are interchangeable throughout the different programming languages. So if you were familiar with JavaScript, if you've gone through a JavaScript course or any other coding course, you're probably familiar with these, right? I believe in JavaScript, if I remember from the top of my head, it's like to uppercase, right? Where here in Python is just upper, right? Same thing with the lower method. In JavaScript, it's to lower, instead of just lower. So the verbiage changes a little bit. There's a little another extra word, and that's okay. But they're fairly similar. So if you can do this in one language, you can kind of do it in another. As long as you're aware that these methods exist, you can probably find this with a quick little search or have a little cheat sheet on your desk will always help. We talked about the capitalize, which capitalizes every other every word. As we see here, we have this Python programming sentence, and there's a space between here. And when they invoke the capitalize method on this text, it capitalizes the very first word of the entire string, right? The very first word of the entire string. It does not capitalize the whole thing, but you'll see that it's going to take the whole string and it's going to capitalize it from the very front, right? The one that does all of them is going to be your dot title. It's going to treat it like a title, like a movie title, right? It's going to be smart enough to be able to break off your string into the different words and capitalize the beginning of each word. So title and capitalize are fairly similar, but the way they work is different. The dot strip method is another helpful one. This removes the leading and trading white space from a string. So what does that mean? Well, here we have our text. And strings, as we talked about, strings will also take spaces and even special characters as part of the string, right? The string does not just like mean letters. It's all types of characters, right? So here, this string has a bunch of white space. There's a bunch of white spaces here. You can kind of see it here when I hover over it and highlight it. There's a bunch of dots that's representing the spaces here. And then we have some at the end of the string. Well, the dot strip method is going to remove any kind of character that's specifically white space. And then it returns to you a formatted string here, right? We see what it looks like when we print just the text, which is the white space included. And then when we strip it, we create a different variable, save the result into it, and then we print out this second variable, right? And it leads to this output here where we have the before and after. This is a very interesting method here. The starts with and the ends with allows you to check the beginning or the end of a string for a specific pattern, right? Here, we're trying to search if this string starts with the character pattern of hello, right? And it's going to return to you a Boolean, right? It returns a Boolean, true or false. Now, what happens if I put a space here? So I say, hey, I want you to check if text starts with hello and space. Well, it's going to come back false, right? It's going to check it exactly how you put it in here, verbatim. And if it doesn't find it like that, it's going to return false. Although this string does start with hello, after the O, it is followed with a comma, not a space. So it's going to return with false. So if at any point something does not match exactly how you asked of it, it will give you the false output. So it's very important to be aware of that. So you have cool methods like this where you can see if it starts with or ends with a specific character pattern, right? And I say character pattern because you are able to look for spaces or special characters in your strings. It's not just letters. The find method is a way to search through your string. And it should return, if I remember correctly, how many times it found it in your string, or was it the index? Oh, it's the index. Okay. Sure, I'm going from the top of my head. All right, so we use find, and when it found or when it looked for find, it returned to us 7. Well, why is that? Well, we see here, the P is at index 0, and we're going to check the index after that. Could go from 0 to 1, 2, 3, 4, 5, 6, 7, right? So it's going to return to you the index of where it first encountered it, right? I don't know why this says result 0. Notice also that there's 2 different is words here. but it only returned to the one that it encountered first, right? Which was this one. It did not tell you about the index for the other one. Count is a very popular one as well, and one that people use very often. It counts the number of non-overlapping overlapping occurrences of a substring in a string. So here we want to count the word Python within the string inside of text, and it's going to return 2 because as it goes through the string and counts with Python once and then twice. Right. So this is a really helpful method to see how many times something appears inside of a string. Replace allows you to replace, as the name suggests, occurrences of a specific substring. This one takes two different parameters, is what we call them, right? Whenever you add stuff inside these parentheses, um, the names are interchangeable. You're going to hear the names parameter, or you're going to hear the name arguments, right? Um, when you're defining these functions, and we will get into that today, I believe, they're called parameters, but when you're actively using them, they're called arguments. But we'll get more in depth into that. I don't want to confuse you too much. What I'm just trying to convey to you guys is that it takes two different input items, right? So you see here the first item, then it's comma, and it takes another item in here, right? So it needs two different inputs to work. Whereas if you've seen before, all these other methods, they only took one input, right? Whatever it needed to work, it was just one occurrence of some kind of input. Whereas replace is going to require two inputs, right? The first one is going to be what you want to replace, and then what you want to replace it with, right? So you'll see different methods as we progress through this curriculum that some take more inputs than others, right? Some inputs are optional, right? You don't have to put them. You can just put what's required and it'll still work. And if you want to, you can add the optional inputs. Very similar to how we sliced the strings on Monday, where we suggested where we wanted to start and where we wanted to end. And then optional was how many times do we want to step over something in a string, right? If you guys recall that from Monday. So some things are optional. And if you want to add something on a method, like an additional input, you require this comma. So here we have a string, which is, as we see here, it's numbers, and the forward slash is to represent a date. We call upon this variable called date string, and then we invoke the dot replace method. And what we want to replace is going to be the forward slash. We want to replace it with this dash. I believe it's called what, a hyphen? I don't know. English is my second language. Right, so we replaced it with I see some chuckles. We replace the forward slash with the hyphen, and then we save the result into this new variable called formatted date. We then print both of these out so we can see the before and after of how this works. Because if you recall from Monday, strings are immutable. We cannot change these strings. So we want to replace, quote unquote, something from a string. We have to create a new string, right? If you want it to work, right? Because it won't replace, it won't actually change the original. We're recreating a new string. So when we print this out, we see here the before, and we see the new one that we created of how it looks after we invoke the replace method. But notice that I'm going to print out the string again. This doesn't change, right? These are two different strings, the date string and the formatted date. The split method is another very handful method, which allows you to break strings apart, right? Here we have the date string once again. They invoke the split method on it, and the argument that it takes is what you want to split it, like where do you want this string to be split from, right? So we want to split this string wherever we encounter a forward slash, right? And as you see here, it's going to return the different parts of the string inside of brackets. And this might be confusing for you if you don't have any experience with coding yet, but this is what we call a list, right? And we will talk more about that as we continue with the curriculum. But when you invoke the split method on the string, it's going to go through the entirety of the string. When it encounters the item that you're trying to split it at, it's going to break it off and it's going to add it into what's known a list, right? And every single time it encounters something new, it's going to split it up and add the next item onto the list. And you end up with something very similar to this, where the list is where everything within the brackets here, and every item within this bracket is separated with a comma to let you know how many items are in here and where they start and end. All right, we have the join method. This is a little confusing at first, right? It's a little backwards with how you use it. And the way that it works is you put what you want to join it with, and then you call the method and pass in what you want to join, right? It's a little backwards. And what do I mean by that? Well, as you've seen previously with all the other methods, here we call the item we want to split, and then we call the method, right? Here we say date underscore string. I want to split it up, right? For here, it's a little backwards, right? Here is this is what I want to join it with. I want to join everything inside of split date. Does that make sense? So the way that we wrote it up is different, and this is not common, right? These are one of the small occasions where you're gonna encounter some weird method that's a little backwards. So don't fret like, oh man, there's so much confusion here. I don't know, like, are all these methods just doing their own thing? No. For the most part, when you invoke a method, they usually work this way here, where you call the variable and then you use a dot and then the name of the method, right? This is one of the small exceptions. So we're trying to grab this split date variable. Well, what is the split date variable? It's this, right? It's a list of numbers 0, 3, 14, 20, 24 in the form of strings. Well, what we are going to do is we are going to join them. Well, what are we joining them with? With whatever is inside of these quotation marks. Well, let's see what it looks like, right? It returns to you the dates all put together. Well, there's nothing here to join them with, right? Because we didn't specify anything within these quotation marks. Well, what do we add? A hyphen. Well, now we rejoin everything within here, but we specify within these quotation marks that we wanted to join them together with a hyphen. And you can join them with whatever you want. Let's say 3 hyphens. And it does as such, right? It grabs every single item from that list. And as it grabs a new item, it's connecting it with 3 hyphens. So what it joins it with is going to be within these quotation marks. At first, because they were empty, it just joined them together, smushed them with nothing to separate them apart, right? Which is why it looks this way. And the rest are optional. You can kind of go through these. These are just some other ones that you can be exposed to. Let's go to W Schools. There's a bunch of methods, guys, and then you guys are more than welcome to kind of navigate through. Let's see if I can find a list of them. Right, so there's different types, right? We have numbers, we can work with numbers, we can work with data, numbers, strings, booleans, right? The different data types. Here in strings, you can go to, if you press on the down arrow, you can go to string methods and you can see everything you can do with string. Look at this long list of methods, guys. I do not have the time to teach you every single method, right? I do not. Realistically, a lot of this stuff, I expose you to the information. I honestly have probably never really used 75% of these methods also, to be realistic with you, right? So these are very situational. So you don't need to know all these. Different methods do different things. The longer you're around coding and whatnot, you'll come to see the different languages evolve, and you will see some other methods no longer be used or even work because they're not useful, right? So there's different methods you can use for different things for strings as well as stuff like lists, which we'll get into. We're not going to talk too much about it, but I do want to show you that the different data types all have different methods. I do not have the time to show you each and one of these methods. I'm just exposing you to them, showing you what's the most common and what you guys will find the most useful to be successful in your application. And those are the ones that are in the curriculum, right? But also, realistically, you're not always going to need most of these methods to begin with. If you ever encounter a situation where you need to do something, you can Google if there's a method to do it, and if there is, you can use that method, right? It's always a good way to use that. So as long as you're aware of the capabilities of it, that's all that matters right now. Before I move forward, let me check the chat real quick. Kelly asked for join. Is the dot join similar to how notebooks doesn't require you to type the print part of other methods? No, it is. Those are two different things. And I do want to touch up on that again. I don't know why Jupyter Notebooks does this, but if you don't add the print method, it'll still print it out. That's really annoying. I have to go back. This is the first time I really honestly noticed it, and I never really addressed it. So I'm glad people have brought up. But ideally, you want to put print right before your variables, before your text. Jupyter Notebooks will still print it out anyways, which is very not helpful for you guys because you guys are learning. But just be aware that you want to have print here when you want to display something on your screen. But all right, that covers the first half hour as I promised on Monday that I was going to do to cover what we had left to cover from Monday. So let's go ahead and continue with what we should be covering today, which is going to be the conditional statements and functions. Right? This is going to be lesson 2 of our curriculum. Roger, where is this? Once again, if you go to your directory on the left side, you go to their lessons, you'll find here 2 Python conditional statements and functions, right? The pace of this class is as follows. It's literally exactly how the lesson is right now. Every single day, we're going to do a brand new lesson. At the end of each lesson has their own exercises. The last week of our course is our mini project week, right? Where we bring together everything we covered the last 2 weeks and we put it together in a very small, very, very small version of a mini project to show you how all these different methods, concepts are brought together to solve a coding problem or an exercise, right? I'm sure you've probably already gone through these already and checked them out if you are a curious person. But they start off easy where we kind of like get a big piece of text and then we manipulate this text. Notice like, just briefly reading through the exercise, writing a script to identify the longest sentence by word count. So we would essentially go through the entire paragraph, find the longest sentence, depending on how many words it has, right? They start off very easy. Then we go into something like the phone number scrubber, right? Having this list of phone numbers and then, putting them all into the same format. Notice that it's a little different here. We have some with parentheses, some with spaces and hyphens, some with just spaces, some of them all mush. Some have area codes or country codes, some don't. So we'll bring all the tools and concepts that we learned to do what quote unquote real world stuff would be, right? And this is something very similar to that, scrubbing through phone numbers. It's very common to have a large piece of data and having to adjust them. That's day 1 of our mini project day. Our second mini project is going to be the Powerball lottery. So these are very fun, right? We're essentially recreating the concept of the Powerball lottery with code, right? So this is a very interesting one. And I believe that the last one is going to be poker. Yeah, it is poker. we're going to recreate like poker, like a virtual poker game, using code, right? So that one's interesting. The way that these will work is that we will break up into teams, and then you guys will have like the first half of the class to kind of give it your honest shot as a group, collaborate with each other, talking and whatnot. And then we would come back. If you complete it, you would demonstrate to the class. If not, I do like a walkthrough of how it should look like. So that's the last week. So that's something to look forward to. But the remainder of this week and next week is all actual lecture. So let's go ahead and continue with that. So welcome to day 2 of Python Basics. So we talked about data types, some basic built-in methods, and I say built-in because Python already comes with some methods that it allows you to utilize that better your quality of life, right? It reduces the amount of code you have to write. That way you don't have to manually write code that capitalizes every single word in your string. Or you don't have to write a code that finds how many times something occurs, right? These are just common things that most developers needed, so they created built-in methods that just come with the coding language. Today, we're going to talk about conditional statements, which is your if-else or true or false, right? And then we're also going to talk about creating your own functions, right? Or your own methods, right? We've been using the word methods, but methods are just another fancy word for function. So we'll be talking about that today as well. So we touched up a little bit on Booleans already, so this should not be completely new. But your Boolean values is going to be your true or your false, right? Whether something is or isn't, right? This can be explicitly declared or defined as a result of an expression. This can be very, very confusing sometimes. So let me know if you need me to slow down or explain it in a different manner. To be fair, this curriculum makes it a little bit too confusing sometimes, where I'm like, it's not really needed. But it's just whether something is or isn't. And we'll see that in real time right now. We have an example of seeing the data type of something. We saw this on day 1 as well. But here we have the word true, and we're checking what type of data type is this by using the type method, right? And as you've seen it work before on Monday, it's going to tell you whether it's a string, whether it's an integer, and in this case, the word true and the word false are Booleans, right? So you can use them in plain text, just like we did here, where I'm just go ahead and just say the word true, or we can also assign them to a variable, right? Right here, we create a variable called the Boolean, and we assign it the Boolean of false, right? And then when this gets ran, we see that it prints out the Boolean, and it returns to us the Boolean of false, right? So you're able to use it independently or save it into a variable. I talked about this as well on Monday, but Booleans in Python need to be capitalized, right? They are case sensitive. If I remember correctly, in JavaScript, they are all lowercase. So if you try to code like you were in JavaScript and not capitalize them, you're going to get something that's very similar to this, where it's going to be like a squiggly line, or it's going to be whited out. So just be aware of that. They are case sensitive. And then you'll get an issue here if you run it. Name error. Name false is not defined. It doesn't know what it is. It's not any data type. It's not a variable. It doesn't know what it is. Comparison operators. So Boolean values can be created with Boolean expressions, but we can also use different ways to compare stuff. Whether you can compare something's true or not, You can also compare if integers are less than or greater than using our comparison operators. And these are pretty uh, interchangeable with other languages as well, right? JavaScript has it as well. If you're familiar with JavaScript, it differs very slightly. And the one that it differs is going to be the equal sign, right? That's equal to equation. In JavaScript, you're able to use 3 equal signs, right? In Python, we don't. All right, in Python, we only have the 2 equal signs. In JavaScript, you're able to check if something is the same data type as well. It can be very, very specific. So in Python, we don't do that. We only have the ability to use the double equal sign, right? One thing to consider or to keep in mind is it is not the same as assigning something into a variable, right? As we see before, when we assign something to a variable, we use 1 equal sign to show the ownership. Like, hey, I'm assigning the Boolean false to the variable called the underscore Boolean, right? When you want to check if something is equal to another item, you use the double equal sign. But what if you want to check if something's not equal to it? Well, instead of using the double equal signs, you replace the first one with an exclamation mark, right? Uh, you'll see the exclamation mark a lot when you're trying to see if something is not equal to something. So this will be an easy one to learn because other languages do something very similar as well, right? Not equal to, we typically use the exclamation mark. And as you're probably familiar with, greater than or less than from elementary school, the arrows, either facing to the right or facing to the left, is going to determine whether something is less than or greater than, and depending on what side they are of the symbol as well, right? So these don't change. These are your basic elementary math classes, whether something is greater than or less than. But you can also check if something is greater than or equal to, which is pretty cool, right? So you can check if something is greater than or equal by using a similar concept to how we checked if something was not equal to something by using the exclamation mark followed with the equal sign. We do something very similar with the greater than or less than followed by the equal sign, right? Do you have any questions so far? Okay. That's pretty straightforward. We have 36 people, which actually makes me really happy in this chat right now. Because typically day 2, we lose like half. I don't know why. People just like, oh, this is not for me. So I'm really excited to see all of you guys in here. And a lot of y'all with your cameras on makes me really happy. So thank y'all. Just want to give that quick shout out before we continue. So here we have the first example of the comparison operators. We have 2 different integers, right? We have the 23 to the left and the 32. We know these are not equal to each other. But let me go ahead and do it how this should be. We're going to use the print method to wrap it around with our quotation marks. As mentioned, Jupyter Notebooks is an individual and likes to do its own thing, and I don't like it. So let's go ahead and use the print method. But when we run this, it's going to print the result of what comes back from this comparison, right? Because this is a comparison. The double equal sign is checking if 23 is equal to 32, and it's going to return to me a Boolean, right? So when I print this out, it's going to return to me false because, as we know, these are not the same numbers. They're not equal to each other, right? We can change the first equal sign to an exclamation mark. And if we run this again, this time it's going to return true because this is correct. 23 does not equal 32. Therefore, it's going to return to me true. So here we do a comparison, but this time, instead of just leaving it independently, we're assigning the result into a variable, right? We're assigning the result of 450. Is it less than 350? Whatever returns from that, we're going to assign it to the variable Boolean underscore 1, And then I want to print out whatever Boolean 1 has, and it should be false, right? So we're able to save the result of a comparison into its own variable and then print it out as well. Earlier, we compared the numbers 23 and 32, just the raw form of that number, we just compared them right off the bat. This time, instead of doing that, we are assigning these integers to a variable, and then we are comparing these variables instead, right? So num1 gets the integer 8, and num2 gets the integer of 6. And then when I print the comparison of these two variables, it checks out that 8 is true, right? Because 8 is greater than 6. So we can either do the comparison to the raw data formula itself, or we can save it into a variable and then compare the variables, right? Membership checks. I love membership checks, right? As the name suggests, memberships. It's checking if something is a member of a certain group, right? Membership operators are used for a membership check. And the operator is the word either in or not in, right? One of the things that I love about Python, it's so English friendly, right? Where other languages they can start using weird verbiage. Python's like, I don't care for all those extra words. Why use a lot of words when small words do the same, right? So we use in or not in. So in is going to check if the left side of the expression is contained in the right side of the expression, right? So what does that mean? Well, let's see in real time. It'll make more sense, right? But in is going to check if the left side is in the right side, and not in is going to check if the left side is not contained in the right side expression. Let's see that in real time. Here we have a list. And once again, I know we haven't talked about lists yet. Just bear with me. It's just a group of different data types. Here we have a list of integers, right? That ranges from 1883, and it seems to be like they're in order, and they go all the way to the year 2021, right? And I only say year because the variable name claims to be blizzard years, right? So I can make that assumption that these are probably the years of when there's been blizzards, right? So after we create our list of different blizzard years, we are going to do a membership check, right? We do here, we check if 2017, the year 2017, is in the list blizzard years, right? So going back to the definition, the in operator checks if the left side of the expression, which is 2017, is contained in the right side of the expression. So as I mentioned before, it's checking if something exists in something else. Simple as that. This is also a comparison, right? It's a form of a comparison operator in a sense as well. So this is going to return to you. What do you think? What kind of result is going to return to you? A Boolean, right? So return a Boolean. I see a thumbs down there from Trevor. Yeah, it's probably going to return false if it's not in here. And as I go through the list, I don't see 2017. I see 2015 and then 2018. But it is checking. It's some form of a comparison. It's checking if something exists in something else. And because it doesn't, it's going to return to me a false result, right? Let's put this in print. Yeah, it's going to return to me false. So membership checks if something exists in another or if it doesn't exist in there, right? Let's do a not in as well. 2017 not in STO blizzard years, which should return true because it's not in there, right? So not in or in, it's a very helpful tool. So this is one that you should really kind of put there as in your tool belt. It's always helpful to use in or not in. Logical operators. So we're able to combine different expressions by using the and the or, and we can also use a not keyword to check the opposite of something, and that'll make sense in a little bit. But for those of you very familiar with JavaScript, when you're checking multiple items, whether it's you're trying to check multiple of the same things or the one or the other, in JavaScript you use the double ampersands or the double pipes, right? We don't do that in Python, right? We're a little bit more civilized on this end, right? We use our words, right? Instead of using the double ampersands or the pipes, we use and or, right? Because we've been educated, so we're going to use and or instead. And how do we use that? Well, here we're doing a logical operator, sorry, we're doing a comparison between 10 and 8. We're checking, is 10 greater than 8? And is 23 less than 25? So we're checking two different things. What do you guys think we're going to get from this? Correct. We're going to get true. No one said anything. But yeah, we're going to get true, right? We're going to get true if both of these check out. I see Devin K. I cheated. I clicked run. Yeah. So we're going to get true, right? 10 is greater than 8, and 23 is less than 25. Well, what happens if 23 is less than 22? Let's change 25 to 22. Well, one of these operators is not going to be correct. So when we run this, this is going to return false, right? It's going to return false because we are checking two different ones. And this is going to differ from the keyword of or, right? When we use and, both of the items that we are checking need to pass. Both of them. If either one of them fails, then the entire thing fails, right? The entire thing fails. That's what the and is doing, right? If I switch this to or, as someone suggested in the chat, this works now, right? Because 10 is greater than 8, and even though 23 is not less than 22, this is still going to return true because we use the or operator. I want to check, is 10 greater than 8 or 23 less than 22? If either one of these bad boys is working, is correct, I'm going to get true, right? So that is the difference between using and or. So you have to be very careful of how you chain these comparison operators, especially if you're looking for a specific outcome, right? So when we use the or, they both have one or the other has to pass, but when using the and operator, both left and right need to be able to reach the same outcome, right? So be very careful with these. All right. Now let's look at the membership checks, right? The next example here is 9n, and we see here a list of different integers. This is checking whether 9 exists within this list, or w in the string, which seems to be like a coordinate, right? Or like a direction. So we're trying to check whether 9 exists within this list or if w exists within this string. One or the other, right? Because we're using or. And when we run this, we're going to get true, right? Because w does exist within this string. At the very end of the string, we have the w. And even though 9 does not exist within the list, because w does, and we're using the or operator, we do get the true. If this was and, we would get false because both of these have to come out to true to give me true. What do you guys think this is going to give me? We have this comparison in here. And it's saying, hey, is 4 not 5? That's true.
Yeah.
Right? That is true. Right? But because this comes out to true, what happens with this not? Well, we talked about it a little bit earlier, but very, very briefly in passing. Let's go back up here. We have the not. It says it negates the value of a Boolean statement, right? It negates it. So whatever this Boolean value comes back to, it no longer valid. It's going to be the complete opposite, right? It's opposite date, right? So although 4 does not equal 5, which is correct, because we put the not operator, it's going to give me the opposite of whatever comes back from this. So therefore, Boolean underscore 2 returns to me the Boolean of false. All right. Hopefully that wasn't confusing. It's just going to give you the opposite of whatever a Boolean is. Just be aware of that. Right? It negates it. Time is 6:55, guys. We're going to take our first 10-minute break of the night. Let's go ahead and come back in 10 minutes. I will see you guys here at 7:05. So when we went on break, we finished off talking about the and or not operators. As a matter of fact, I don't think we finished. Where did I leave off? Oh, the having a complete Boolean expression, right? So here we have a very similar check as we had before, right? Where we checked if something existed within the Blizzard years, right? If you guys recall this Blizzard years list, we're redoing something very similar to that. Where here we say print, and in the print statement, we're checking if 2014 and 2018 is in STO Blizzard years. And we get something a little weird, right? We print out the results of this membership check. Can you guys hear the dogs in the background? Okay, thank God. They're losing. Yeah, but we have the print statement here of the membership check of 2014 and 2018 inside of the STL Blizzard years, and we're also printing out the entirety of the Blizzard years. Now let's see, does 2014 and 2018 exist? When we scroll through here, we see 2014 does not exist, right? There's actually a gap between 2010 and 2015, and 2018 does, but this returns true, and it shouldn't return true. Why should it not? Well, for one, yeah, 2014 isn't in the list, right? And also, as George says, we're also using the and operator, right? So both of those are correct. For those of you who said it in the chat, right? Because 2014 is not in the list, but we use the and operator. Both of these need to pass the check, right? Because that's what the and is for, right? If this was like the or operator, then it would make sense. Like, okay, well, this is okay if it returns true because technically one or the other has to pass the check, and that's all it requires. But there's an issue here, right? For some reason, it's still returning true, even though 2014 is not in the list, and we're using the and operator. And that's because we have an incomplete expression here. We need an extra in operator. That is correct, right? Mark Bruno. So we're supposed to complete this expression, and it should look something very similar to this. If 2014 in STO Blizzard years and 2018 in STO Blizzard years, right? This would complete the expression, right? Python was not smart enough to know what you referred to by typing this out in this manner, right? We need an individual in expression for both of these checks, right, to complete the expression. And now when we run this, it should return false because now it will successfully check for both these. It's 2014 in the Blizzard years, and it's 2018 in the Blizzard years, right? Before it was incomplete. All right, so you want to be careful with uh, these incomplete expressions. That should complete those operators. Let's talk about the if statement. I love the if else statements. You're gonna be using a lot of this. Who's into video games? Y'all like video games? All right, okay, that's awesome. If you guys ever decide to dabble into video game logic, uh, you're going to realize that about 50% of the code in your game is a bunch of if else statements. It's going to be something very similar to this, like, hey, if the player is alive, then you should be able to move. You know, if the right key is being pressed, then increase the X or yeah, the X axis of the character's location by a positive amount, right? If he's touching the floor or if something collides, do this. It's a bunch of if else statements, um, which is pretty cool. So just by knowing if else here in Python, you already know 50% of how to complete a game. I promise you. The rest of it is just learning the game engine. The logic, a lot of it is literally all if else statements. Um, I've done a couple games myself. So let's go ahead and talk about if statements. All right. Uh, Sometimes when we're running some code, we have different things that we want to check for, right? As my previous example, right? And we only want certain things to run if certain conditions are met, right? The if statement allows us to do that, right? It allows us to make decisions. Um, Here's our first example, right? We create a variable called temperature, and we assign it the data type of an integer with a value of 70, right? And the way that this works is uh, you need the keywords if and else, right? It starts off as you see here. We say if, then we get the variable we want to check for, and then we give it the condition, right? This is known as the condition. If temperature is less than 32, right? This is my first condition. If this comes out to true, I want to do the following. Well, how do I start a new code block, right? So after completing this condition here, I follow it with a colon. This lets Python know, hey, I'm about to go deeper into my code here. I'm going to start a new code block that should only run if this passes, right? So we do that colon. We go to the next line and we press the tab to shift our code to the right. Now, this code here will only run and exist if this passes, right? If this equals to true. So if the temperature is less than 32, I want to print out the string that says there could be a chance of snow, right? Now, what happens if this doesn't work? This fails, right? Temperature is greater than 32. Then by default, the next line of code that's going to be read is going to be the else statement, right? It's going to skip this because we did not pass this if check, right? When it checked to see it was less than 32, it fails, so it defaults to the next option, which is else. So else, and notice there is no condition here, right? If this doesn't pass, it automatically runs the else statement. No if, else, or buts, right? No pun intended. It goes to the else statement, and it runs whatever is within the code block of the else statement, right? So once again, it opens it up with a colon, goes to the next line and indents it to signify the start of this cell of this code block, and we print out there is probably not going to be snow, right? So we're going to check one or the other. If it's less than 32, do this, else do the other, right? And this is the beauty of if-else statements. It allows us to take different routes. Some of the most basic coding exercises when you first start coding it's almost doing like a Dungeons and Dragons like roadmap. Like you create a character and you're like, what role do you want to go, left or right? And then you choose the option, right? And then you select option A, then it gives you like this prompt telling you a description that, oh, you walk down this, this shadowy road, and there's like, it's a barren wasteland. You hear like the animals, whatever. I'm not a Dungeons and Dragons player, but give me a small example here. And then it tells you like, oh, you encounter this person, right? What do you do? Do you ignore them or do you talk to them? All right, and you do an if and else check, right? So one of the most basic coding exercises are doing like a small little story where you take different options and have different dialogue, which is pretty cool if you want to try that out to practice your coding. So what if we wanted to add multiple options, right? What if, it's not just if else, but I have different possibilities of doing different things, right? The next thing we're going to introduce is going to be the if else, right? The if else, or the else if, right? Specifically in Python, we call it elif for short, right? Else if. This should look fairly familiar to JavaScript. I'm sorry, I'm trying to keep up with the chat real quick. Let's see. I learned this because someone used Logic Gate to make Pong in Terraria. Some Terraria players, that's cool. I love Terraria. Tree energy is correct. Yeah. So here we have, once again, building off from the previous code block, we have the temperature being 70. And here we're going to check if the temperature is less than 32, right? And notice that once it passes this block of code, this check, this condition check, it goes even deeper, right? It opens up another if statement. If the temperature is less than 10, then I want to print out it's dangerously cold outside. And this is a little confusing because we just covered else statements. I don't know why we didn't add it here. But this is what we call nested code, right? It's nested within itself. So we start an if else check, right? Once if we pass the temperature less than 32, we go to the next code section, which automatically starts another nested if else check. It checks if the temperature is less than 10. And if so, it's going to print out it's dangerously cold outside. If it's greater than 10, but less than 32, it's going to print out what ends up in the else statement where it says it is literally freezing outside. Stay inside with jammies and hot cocoa. It's willily freezing outside. Willily. And then in the event that for whatever reason, this does not pass, well, what happens? Well, it's not going to default straight to the else because we have an elif. We have an elif statement, right? So we have different options. If the first if statement doesn't work, well, we can go to the next if statement, right? Or what we call it elif, right? So if it's less than 32, I want to do the following. If not, let's check if it's less than 55. If so, then we want to say layer up and stay warm. If none of these pass, then chances are the temperature is greater than 55. So it's going to be warm. So we should say something like, looks to be a nice day, right? So we have different options here, different routes we can take within our code, depending on the conditions that we have set, right? So this lets us take different routes and say or do different things depending on what conditions we pass and which ones we fail. You would typically see logic trees constructed like the one above, starting with if or elif, which is short for else if, right? And then your final catch-all, which is the else. If nothing else succeeds, then just go to the else statements, right? That's what that means. Right. So earlier you saw this without the else statement. So let me just cover that before I move forward, right? We said that the else statement is a catch-all, right? It's going to catch whatever, if nothing else happened, then it should just run this. But with that logic in mind, what happens if we pass this check right here. Temperature is less than 32, right? And we come inside this code block. The first line, we're checking if it's less than 10. What happens if this doesn't run and we don't pass this? Well, it's going to skip this line and it's going to go to the next line anyways. So by default, it's still going to print this out. So it's almost redundant sometimes to put an else check, right? Because as we said, with the same logic of the else statement, it's a catch-all. So if what's above doesn't pass, by default, it's going to run the else statement. So therefore, does this really matter? So we didn't add the else statement here, but it'll still do the same thing. Does that make sense? So with the same logic, if it's still going to run the else check, then why put the else check? Just go ahead and print it out, right? So it just saves you another line of code. Whether you add the additional else check there or not, it's up to you guys. There's sometimes where you're going to need it, regardless, to prevent certain occasions to happen. But we'll talk more about that later on. All right, because what if you wanted to add some more else statements in here, right? But you know, for the most part, you can kind of omit it because it's still going to run the next line of code anyways. So it is what it is. So here we have temperature is equal to less than 60. I haven't ran this in so long, so give me a second. All right, so temperature is equal to less than 60. If temperature is less than 55, we want to print layer up and stay warm. Well, it's true, right? Temperature is less than 55, right? But notice that our temperature is negative 60, so it's also less than 32, right? So both of these are true, both the if and the elif. But when we run this, it only prints out layer up and stay warm, right? Because it did not take into account what if it's even lower, right? So just keep in mind of how you structure your if or elif statements, right? Here we took into account the situation where what if it is less than 10, right? Sure, it might be less than 32, but it's also even, it might be even lower than 10, right? Where here they didn't take into account, right? Although the temperature is less than 55, it's also less than 32. But the moment that one of these if or elif statement passes, that's it. Nothing else matters here, right? Because it's going to go into its code block and it's never going to see the other lines of code because it passed this one. So we stuck to this one, right? Make sense? So just be careful with how you structure your code. Your code is going to do what you tell it to do, right? Are any of you guys familiar with the video? It's a funny video on social media where this guy has these two kids. He has a guy, a boy and a little girl, and he's trying to show them, how to be specific with what they want. So he gives them an exercise. I want you to write me the instructions or the directions of how to make a peanut butter and jelly sandwich, right? So these kids get this piece of paper and they start writing, get a piece of bread, put some jelly on it, put the peanut butter on it, put the pieces of bread together, and then eat it. So the dad gets the peanut butter and jelly jars, he gets the piece of bread, and he does exactly how the instructions go. It says, grab the piece of bread. So he grabs the bread with a whole loaf. And it says, put the peanut butter on it. So he grabs the entire jar and then places it on top of it, right? So he deliberately does what the kids tell him to do, but it's not exactly how it should be done, right? You're supposed to open up the bag, take out, two pieces of bread, get a, knife, get your peanut butter, using the knife, go through the whole process of actually making it, spreading it on your slice of bread. But he's very deliberate with what he does because he's going exactly with what the instructions tell us to do. Your code is exactly like that, right? Your computer is going to do exactly what you tell it to do, right? So you have to be very specific to, with what your code is and what kind of outcome you want it to reach. Because if it doesn't work, it's nobody's fault but yourself. So just keep that in mind, right? Your code will only do what you tell it to do. I see you guys recognize it in the chat. Yeah, it's a really funny video. I love it. It's literally exactly like coding. All right. You guys can try this out. We have some, student examples. So you guys can go through it on your own time and make this work, right? You kind of already saw like a working example of how that should work. So if you guys want to try it out on your own, you can take this piece of code and then kind of run it through here, see if you're able to get it work as intended, right? So that's going to be up to you guys. But we still have a lot more to talk about, so we're going to go ahead and move forward. The next thing we're going to talk about is going to be Python functions. Functions is probably one of the best parts about coding. And it's a very important part. Uh, Typically, a lot of coding boot camps tend to introduce Python, or not Python, tend to introduce functions very later into their courses. We teach it very early uh, to help hopefully get you better in the right mindset to understand them, because they can get very confusing, right? Uh, you've already been exposed to functions, whether you believe it or not, right? On Monday, when we talked about it, and today, when we talked about it in the beginning of class, right? These methods that you saw, the dot title, dot capitalize, print, print is technically a form of a function, right? These are all built-in functions, right? You don't know how they work, but they do something, right? Somebody somewhere, whoever created Python, they hard coded this function, and then you are invoking this function and utilizing, taking advantage of it, right? So we're going to talk about how do we create our own functions. I see here Excel. Yeah, Excel. It's actually somewhat similar to that, right? You have different functions in Excel as well. We're going to talk about creating our own functions, and I think they recently. I don't use Excel too often, but within like the last year or two, right? They added the ability to create your own functions. Is that correct? I'm not sure, but yeah, so we're going to talk about creating lambdas, right? So we can create our own functions here. So if you have some kind of experience like that in Excel, even better, right? Very similar to that. So we're going to talk about Python functions and how they work and how we create them, right? Functions is going to be one of the most important skills to understand with the programming language, and it's interchangeable between all other languages, right? All these other languages also have functions. The way they create them is a little bit different than others. They have different syntax, but functions are the same all across the board, right? So why do we use functions? Well, for one, they are reusable, right? And it helps you to prevent yourself from repeating yourself, right? We tend to operate what we call the dry method, right? Don't repeat yourself, right? If you have a lot of code that you're going to have to continue typing out, why not just create a function that you can invoke that just does it for you every single time, right? Instead of having to manually code out this piece of code over and over again, you just create it once in a function, and then just call the function in, so it does it for you, right? So it helps you kind of streamline your code a little bit. It keeps you from repeating yourself. It organizes it better, right? So you have less code with the same capabilities, right? And it looks cleaner and neater. We introduced some functions already using the built-in methods. And here's the first example, right? Utilizing the capitalize method, right? So here we have a variable. Let me see if I can. There we go. I have my computer zoomed in for you guys. So here we have a variable called my name, and we are assigning it a data type of a string, which is my name, Roger, right? We then create a new variable called capitalized name, where we call the previous variable my name, and then we invoke the capitalized method. The capitalized method is a built-in method, which is just a fancy word for a function, right? It's a function that comes with Python, right? So we call the capitalized method, and by default, methods need these parentheses. So even if they don't take any arguments, we still need the parentheses because that's how you call a function, right? You can kind of even hover over it, right? It's a method or a function. It doesn't take any arguments, but it is a function. So we call this function or this method, and it's going to do something. As we saw already earlier, capitalize is going to capitalize the beginning of my string. So this should return Roger with a capital R, and it does as such. Well, how does this work, Roger? Right? It's not magic, right? Believe it or not, it's not magic. There is actual functionality behind the scene or behind the screen, right? You just don't see it. So we're going to talk about it. We're going to kind of create our own functions here. We're going to start very, very slow and from the bottom, right? So what do functions take? Functions can take inputs, right? And I've used this word already earlier. There's different amount of input some functions take, some take less than others. The capitalized method took no input, right? There's nothing within these parentheses, right? These inputs are called parameters, right? They allow you to pass in data into the function, right? So we can set up different parameters in here that take in input, and it uses that input to function, right? The parameters can be whatever we desire, right? Very similar to how when we define our variable name, whatever, float your goat, that's what you name it. So we can create different parameters and name it whatever we want, right? But the parameter should be given a name that lets you know what type of data should be passed in, right? And we'll see that in real time. Now, how do we define a function? To define a function, you need to use the def, right, keyword, which is short for define, right? And it's going to be followed by the function name and then the parentheses, right? And the parentheses is where we're going to define the parameters. And here's our first example, right? When we define a variable, we didn't use some keyword like define. We didn't use some keyword like in JavaScript, how you use let or const, right? We just went ahead and just gave the name of a variable. We just called the variable itself, right? A function, it requires a keyword, right? That's how Python is able to identify what's a variable and what is it. Like, oh, this is a function, right? Because you have the define keyword in here. So that's why the define keyword is important. In other languages, there's different keywords that they use. The way that we do it in Python is by using the def keyword, right? So we use define, and then we give it a fancy name, something that should give you an idea of what this function does. Capitalize is a pretty straightforward thing. What does capitalize do? It capitalizes your string, right? So, at first glance, when you read the name of the function, it should give you some kind of an idea of what the functionality of this function is. Sometimes, people give it very abstract names, and it can be very confusing. So be a good developer, give it something relevant, right? And then after we define the name of our function, we open up parentheses, right? And here is where we are going to define the different parameters that our function is able to take, right? What we are able to use. You can give it as many parameters as you really want. I don't think there's an actual limit. And they're not all mandatory. You can set defaults. You can make them optional, right? And we'll see that in a bit, right? But here we have the function total sum, and it takes in 1 and 2 different parameters. So 2 different parameters, num1 and num2. When you are defining a function, what you call these parameters doesn't really matter, right? These don't really mean anything. It's for your knowledge only, right? So when you go back and read through your function, the description of your function, and you want to know what ingredients, right, your recipe may take, or what your function takes, you need to know what is supposed to go in this section, right? I can kind of make some, guess here that I'm gonna take one number and I'm gonna take a second number, right? Just by the name of the parameter. So whatever you name the parameter in your definition, it doesn't matter. It's as long as it's something very relevant to the function itself. Right, the inner working of the function will usually contain conditional logic to get to a result, right? Everything indented under the first line of the function is the inner workings. So very similar to how we started the if-else check, right? Once we declared the if statement, we started with a colon to go inside of that if-else statement and write some code. We're going to do something very similar to our function. I see a question in the chat. Is this specific method directly tied to the string data type? Could you elaborate a little bit more in the chat, please? I'm a little confused. But
I was asking about the capitalized method. Is it directly tied to the string data type?
yes. And we can honestly recreate this, and I'll show you how it probably works behind the scenes. But yeah, it's directly. It only works with a string. I'm pretty sure if you try to use an integer, it's gonna give you an error, right? And you're gonna see that work in a bit right now too. But that's a good question. Thank you, Andy. Is it your name Andy? Andy? Andy. Okay.
Yeah, just Andy. Andy's fine.
All right. Right on. Okay. Yeah. So we'll see that in real time here, Andy. We have here, in addition to the total sum, here we have the example of what it should look like, right? It's not complete, by the way. But I don't know why this is like this. Let me go ahead and skip this. We'll come here. Right. We defined the function called total sum. This is a definition, right? We are creating the definition. Right. This is the blueprint to the function. So in the definition, the blueprint, wherever you're defining and creating this function, that's where you're going to add the whatever these parameters should be. And these parameters are going to be num1 and num2, right? You can see here, I hover over it, it says parameter. It says num2 is equal to any, num1 is equal to any. So it's not tied to any real data type, right? It says there any, right? I think I can do string. And now I gave it a better description of what it should be. So it doesn't require you to do this to add the colon string. You can, a good developer would, right? Especially if you have multiple parameters, it can get very confusing. But to keep it simple, I'm just gonna keep it as num1 and num2, right? So after you define it, you go inside the function, you indent, right? Make sure you have the colon. And here is where you are actually gonna add the functionality. Well, what are you gonna do with these parameters? Well, I'm going to create a new variable called sum. And then this sum, I'm going to grab the parameter of num1, and I'm gonna add it to num2. And then I'm gonna print sum, right? And when I run this, notice here that I'm calling the function total sum, and I'm passing in the integer of 2 and 3, right? I passed in two different inputs here, two arguments, right? Because I know that the way that I created this function, I set it up that it requires two arguments. And then it uses both of these arguments inside of its logic. So it's going to require it. So what happens if I don't add that second argument? Well, when it tries to run, it's going to say, all right, I'm going to grab num1, which is 2. Awesome. And I'm going to add num2. Well, where the heck is num2 at? You didn't give me num2. And I'm going to yell at you now, right? So it's going to give you an error. So it's important, when you define your function, you're going to have to give it the parameters that you set. So let's run this. Let's see what it does. Well, we see here it ran twice. The first time it ran, it printed out 5, which is correct, right? The first time this run, it ran well. It did what it should do. I don't know why this squiggly line, if I'm being honest with you. This is wrong. I believe this is just Jupyter Notebooks being Jupyter Notebooks. But the first one is correct, right? It got the 2 and the 3, it added them up, and then it printed out the 5. Right? Well, the second time, I got an error, right? A type error. And it says total sum missing one required positional argument. And then it even repeats to me the name of the parameter it's supposed to be, num2. Well, what's num2? It's supposed to be the second parameter, right? So the parameters you pass in, if you're using them in your definition, you're gonna get an error if you don't pass them in. But what happens if I remove it from here and I don't use num2? I'm only gonna use num1. Although in my definition, I'm adding here that num2 should be passed in, right? Or there is a second argument. I'm not even using it. Notice that the moment I took off num2 from the definition itself, the parameter went gray, right? It's not as bright as num1. Well, let's run this. The first one still works. I get num1 plus 5, which is correct. It works, right? It didn't add the num2, right? It just added whatever 2 was to the 5 that I hard coded within this function, and it gave me 7. That's correct, right? The second one still gave me an issue, right? Even though I set this to not take num2 in the actual definition, I have num2 here as a parameter. So when I try to run it, even though it's not being used, it's still going to give me an error, right? Type error, total sum missing one required positional argument. All right, so it's something to take into consideration, right? When something's not being used in your code, it typically gets grayed out as well. So that's an easy identifier of it. What if I do this? Is this going to lock it in? No. It's still going to work, right? Notice here that num1 and num2 still get added up, and it gives me 5. Even though in the definition, I added here that this should be a string, this doesn't lock it in, right? This does not lock the data type. This right here is for the developer, all right? For you to know how to use it. But if in your code, you're still utilizing it as if it's a number and you pass in a number, it's going to treat it as such, right? This does not lock it in. So keep that in mind. Right, I can change this to strings. So give me a different output, right? 23. But it adding the string here does not matter. I do this only to show you that you can add some additional verbiage in your function definition to help you in the future as a developer understand what your code is doing, right? Especially if you have a very complex function that takes multiple parameters and you're working in a group setting with other teammates and they're using your functions, it can get very confusing, especially when you have different data types. So that's a very helpful way to define your stuff if you want to ensure there's like clarity on what stuff should be, but it's not mandatory. I see a question here. How would we write this function in a way that would dynamically add and subtract the parameters based on the user parameter needs? I.e., person 1 has 5 parameters for the function, but person 2 has 9 parameters. It's a little out of scope, Chris, but I would probably take in a list of numbers. And then I would, like I said, out of scope. I don't know if you're familiar with for loops yet, Chris, but I will loop through my list for a num and list of numbers, right? I'm just doing it real quick. I would create a variable where I have like, oh, my bad. What do I do? I would create a variable where I would add each number that I loop through into it. So I'll do sum plus equals num, and then I will print out sum at the end, right? So this, depending on who uses my function, they might have 2 items in the list. They might have 100. Either or, I'm gonna loop through the entire list and then add them all together. Hopefully that answers your question, but it is a little out of scope, so I don't want to confuse too many people. But there is ways to make your function work to be specific to your needs, right? Let's get back on track. Hopefully that answers the question. But yeah, so once again, from top, we define a function with the defined keyword. You give it a very relevant name that pertains to what its functionality should be. You're able to define multiple parameters or no parameters at all. You can just say 5 plus 5. It's hard coded in here, but every single time you run this, it's gonna just run 5 plus 5, right? So there's different ways to do this to fit your needs. As of right now, we have it set that it needs to take in 2 parameters. It's going to add these 2 parameters into a variable called sum. It's going to print out sum. Now, what if we wanted to save the answer from total sum into a variable so we can use it? Well, here is my function again. There's something different here than we had before, right? Above, we added num1 and num2, and then we printed it out, right? That's all we did. Right here, we're not printing it out. We are invoking this method called return. Return sum. But what does that mean? Well, what's happening when we run a function? Well, what happens is temporarily, and it's very, very brief. The code takes like a millisecond to run. But very briefly, when your code runs a function, it dives into the function, right? Think of it. How can I explain it? It puts a pause on everything else in a sense, and it runs everything within the function, right? And it's almost like entering a separate room, right? Imagine your code from top to bottom is like a hallway. You're running down this hallway, right? You're going through your lines of code, and you get to a section in your code where you have to run a function, right? In this analogy, you're going to open up a room in this hallway and go inside of it and do some kind of action, right? That's you running this function. Well, whatever you do inside this room or inside this function, it's going to stay in there, right? Unless you bring it out back into that hallway, right? Or back into your code, right? What we call the global scope, right? Whenever you go into a room or inside of this function, you're going to a local scope, right? Into an area that's outside of everywhere else. A little bit, I guess. Inception, right? But because of that, when you run this function and you go to sum up num1 and num2, you're currently within a room outside of the hallway, right? You're not in the hallway no longer. You're in this little area inside of this function running some kind of, math. You add up num1 and num2. Well, how does the rest of your code have access to this information? Well, we do that by saying return. Hey, I want you to return back to the rest of the code this, right? In this situation, we're returning sum, right? So after total sum runs, I want to return from this function whatever sum is, right? So whatever returns from this function, as we see here in this line of code, I'm assigning it to the variable of sum, right? Notice that sum here and the global scope of your code is not the same as sum inside of your function. These are 2 different parameters, right? They exist in 2 different existence, I guess, is a way of putting it, right? In 2 different scopes. Whatever is inside of this function, it only exists within this function unless you return it, right? The outside of your code, that is like the global scope of the rest of your code, right? The main character, I would say, right? Main character energy. So you have to return the sum. So once this code runs, it returns a sum and it saves it into a different variable in the global scope of your code called sum. And then we print it out. Right? And it works. This is how we intended it to work. But what if it's just like this? Let's go back to how we had it before, where we had print sum instead of return sum. So let's go ahead and we change this. Instead of return, I'm doing print. Why am I getting? Oh, okay, my bad. So we run this, and let's actually remove this one. Okay, we changed it back to print sum, right? And when it runs, it's still working, right? Because when this code runs, this function, it's gonna print the sum anyways, right? But notice right now, when I try to print the variable that I'm saving this function in, it says none. Well, why does it say none? Well, although we're printing it within the function, it's not returning anything. So when I call this function total sum and I'm assigning this to the variable called sum, and then I try to print out sum, that prints out none. Let's remove this print statement. At no point this function is printing sum, and at no point are we returning anything. We're just going to go ahead and run num1 plus num2 is equal to sum. And let's see how this works. Well, I get none. Well, why is that, Roger? Like, we ran the function, and then we save the result inside of the variable called sum. And I'm trying to print out, why isn't that working? Well, because we never returned anything, right? When this function ran, right, when we went to the room and we did this math, I never returned anything from it, right? Which is why you require the return statements. And now, once again, it's going to return the output of whatever sum is. It's going to save it to a variable, and I can print it out, right? Earlier, when all I had was print, when this function runs, yeah, it's going to print out y. But if I try to save the result of the function into a different variable and then use it somewhere else, just that variable, it won't work. It's going to say none because there's nothing that ever came back from it. Sure, you printed it out, but you never returned anything back to the global scope. So you weren't able to save it into a variable somewhere else. Does that make sense? Awesome. So if you want to have access to the information that happens within your function, you need to return it back out. If the return statement isn't used and you attempt to save the answer from your function, you will come to find out that the value will hold none. And we just talked about this, right? Here it is again. There is no print statement. There's no return. It's just the math of it. They run the function with the parameters of 2, 3, save the result into the variable called sum, and they print out sum. And once again, they get none because nothing was ever returned, right? So we weren't able to save it somewhere. Recreating the capitalized method, right? It's not magic. There is some kind of functionality behind it. It is not magic, and here it is, right? This is what's probably happening, right? I don't know this. I wrote this, by the way. I don't know, right? I can probably look at the code later on, like the code files, but this is me recreating it from just regular code. This is probably very similar to how it's actually written in the code of Python, right? In its files, right? They wrote something like this, and notice that I called my function capitalized name, right? Why did I not call it capitalized?
It's a predefined function.
Yeah, it's a predefined function, right? Good job, Scott. Yeah, it's already created. It's a reserved keyword. It's a reserved method, right? It comes with Python. So I had to create my own customized one. So I called it capitalized underscore name. I just gave it a parameter and I call this parameter target name, right? Once again, whatever you call your parameters doesn't really matter, right? Because this is just the definition. This is just for you as a developer or the user to understand what this code should be taking in. It's going to take that target name, and what I'm going to do is I'm going to grab the very first character of this string, right? So I say target name at index 0, right? That's what these brackets are doing. They're grabbing index 0, right? Back to Monday when we talked about slicing, right? We talked about grabbing the start and the end point of a string. Right now, the only thing we're grabbing is the character at index 0. And then after we grab the character of index 0, right, of target name, I want to invoke the method, the built-in method dot upper. Right, so I'm leveraging a pre-built method somewhere else. And I am capitalizing it. And I'm saving whatever returns from this, I'm saving it all into a variable called capitalized letter. Right? Capitalized letter. Finally, I grab this now new formatted letter in a capitalized way, and I'm going to add it to whatever target name. But notice how I'm doing it. On target name, I only grab the characters from index 1 and to the right. That way, I did not grab the first character, which is at index 0, right? And I joined it together, right, with the capitalized letter. And recreated a new string called formatted name. And I return formatted name. And now when I run this, it does exactly what capitalize does. It capitalizes the first character in a string, right? So here is me running all three functions. I run capitalized name 3 times with 3 different names, and all 3 of them work, right? Roger, Joe, and Adam are all capitalized. You said, why is formatted name necessary? That's a good question. Well, okay, let's look at this example, right? When the first example I used was Roger de la Garza, right? So what is target name going to be? When I run this the first time, the target name is going to look like this, right? What's capitalized letter? As I mentioned to you earlier, capitalized letter, I'm grabbing whatever target name is, I'm grabbing the item at index 0. Well, where's index 0? It is the R, right? The very first character in the string. So target name at index 0 ends up being the lowercase r. And then once I grab that, I use the dot upper method. So this ends up making a capitalized R, right? So this capitalized R is saved in here, in this variable called capitalized letter. But my target name is still the same. It hasn't changed, right? It has not changed. So I need to create a different string that is the capitalized version of my original, right? That's where formatted name comes from. I'm going to create another string. I'm going to grab capitalized letter, which we already identified is currently a capitalized R. And then I'm going to grab everything in target name from index 1, which is here at the O, and to the right. That's what that's doing. And then I'm going to join them together. As we saw, we can join strings using the plus sign. And then I'm going to return the new formatted name. Does that answer your question? Yes, it combines them, Joseph. Ahmed, I believe I'm pronouncing your name correctly. I'm sorry if I'm not. There is a way to do it. Yes, it's not too complicated. It's just out of scope of today, right? It will require you, well, first and foremost, I would probably split this. So I would say like split name is equal to target name dot split. Where do I want to split it? At the space. So there I can now split my name into 2 different words, and it's saved into what ends up being a list, right? How would I handle different words? Well, I would have to start a for loop, and this is why I say it's out of scope. right? Because I haven't taught you that yet, but I will loop through my list, grab every single word, and then capitalize it, right? So once we get to for loops, maybe we can come back to this topic and I can answer that question for you, Ahmed. But as of right now, my bad. English is my second language. It is a little out of scope, so I don't want to get too deep into the weeds right now.
Understood. No, thank you very much.
No problem. But hopefully I answered y'all's questions, guys. Time is 7:59. We're gonna go ahead and take another our second and last 10-minute break of the night. Let's come back at 8:09, and I will see you guys then. We are on the final stretch for the night. We have 50 minutes left. Not too much left to cover today, which is good. We were talking about the capitalized method. Here's another example of using, functions to recreate some of the methods we've already seen. One of them is being the find method, right? So if you recall from lesson 1, the find method will locate the first occurrence of the data path inside the method and return the index of where it found it. All right, but here, this custom method is going to return true or false instead. All right, so we didn't talk too much on these methods, right? The find method, in the event it didn't find it, it will return a -1, right? And that I'm just looking out to show you real quick. So here we have the find method, the definition and usage. So the find method returns -1 if the value is not found. But if it does, it'll return to you the index of the first occurrence, right? So we are going to take advantage of this -1 and use that to set a conditional statement to return something else, right? So here we create a custom method called find name, where we take a target name and the input data, right? So first and foremost, we I don't know why I added this. You don't need that. Sorry. So we create this function here. We have target name and input data. I have a variable called name location that I'm going to declare. It's going to be the result of whatever comes back from using the find method, right? Well, the input data should be some kind of string, right? And it's going to be something like, for example, let's say my custom sentence, right? It's going to be the input data. Right, and what I want the target name to be, this should be, I'm looking for like the first U, right? I'm looking for the first U in this sentence, right? So target name, input data will be what I'm looking for. That's kind of how it's broken down here, right? So I'm gonna grab the word I'm trying to look through, which is gonna be, or not the word, I guess the string is a better word to use here. I'm gonna grab the string I'm trying to search through, which is in this case input data, and I'm going to use the find method. I'm going to look for the U, right? Now, in the event it doesn't find it, I'm going to do one thing or the other. This is where the if else check comes into play, right? So if name location, so whatever comes back from this find method, right? Whatever comes back from this, it's either going to be a -1 or it's going to be some kind of positive number or a 0 to a positive number telling me the index of where it was located at, right? If it's not a positive number or a 0 and it's a -1, that tells me that whatever I was looking for was not encountered, right? So if I get a -1, or if I don't get a -1, I'm gonna do one or the other. So if name location does not equal -1, I'm gonna return true, right? That means I found it. If I didn't, I'm gonna return false. So it's not a fancy method here, right? This method kind of sucks if I'm being honest with you, right? I'm just gonna return true or false if it found it. Doesn't really do too much. But you can see here how you can create your custom method. You can use other methods within your own function, right? You see here how I utilize the if else check to compare between different values. I can create variables within here, and then what I return here is going to be a Boolean, right? So we're already starting to utilize these different tools that we have been learning and slowly incorporating them into our code. And this is what I meant about creating a function that keeps you from repeating yourself. So instead of having to do some form of functionality over and over again, you can create your own custom function that might do something that you know you have to do multiple times, and save yourself some time and lines of code, so it's a little bit more readable, right? And this here is what we call pseudocode, right? When you write comments like this, it helps document what things should be. So definitely take advantage of the comments so you can format this a little bit better and understand what things should be. This is just like a demonstration of what it should be. It helps me as I code along to kind of write out what stuff should be given me, what I should be putting into it, what variable should be what. And it's a habit that I encourage for you guys to start incorporating into your day-to-day coding sessions to ensure that you get better at documentation, and it helps alleviate confusion later on in the future. Anyways, so let's go ahead and use this in real time, right? So here we have a long string of data, which is just a huge string, right, of multiple names, right? And I'm going to use the method I created, and I'm looking for specific names. I'm looking for Roger, Bill Smith, and Frank Scott. It's going to return true or false whether the names were encountered there. And all three of these names were found within here. Let's look for them: Roger, Bill, and Frank. So here's Frank, Scott, Bill Smith, and then I should be somewhere in here. Here I am, right? So it returned true for all three of these. So yeah, I mean, it doesn't have to return true. It can return whatever you want. Return, it's in here. I can't type to save my life, right? Whatever helps you, right? It doesn't have to return a Boolean. You can customize your functions to do whatever you want to do. But all right, let's go ahead and move forward. Earlier, we talked about function scope, so we're not going to spend too much time on here. I'm glad I taught it earlier because I forgot how much of a mess this piece of coding is here. This is a very confusing cell block of code that explains to you how global scope and local scope works, right? In short, let's go to Scally Draw. Here we go. This is one of my favorite websites I like to use. Is everyone seeing my browser right now? Okay, good. This is Ode from a previous class. But TL Draw is one of my most favorite websites to use because it lets me use a whiteboard for free. So let's go ahead and create scope, a new canvas, right? So I'm gonna use drawings to hopefully make this a little easier to understand, right? I want you guys to think of this line as your global scope, right? This is from top to bottom, your code, right? From the first line to the last line. As your code's running, it runs from top to bottom, right? You're defining variables here, and everything that's defined at this level has access to each other, right? This is all the top level, right? Your main code, also, top level, I would say, another way to describe it is the top level of your code, right? And what happens when you create a function is you kind of go into a level below, right? You go downwards into. I'm trying to make this visually appealing, right? You go down a level, right? And you're no longer within your global scope, right? You're a level down, right? And what this is called local scope, right? This is local to only the area in here, right? So what happens is when you declare a variable, like let's say x is equal to 5, because this is at the very top, everything lower in the levels, it has access to the stuff in the global scope, right? So I can access the x variable within here, but it does not go the same the other way around. If within here, I declare a variable called y is equal to 10, it only exists within the local scope of this function, unless I return it, right? Return y. When I do return y, what this does, it brings back a value or a variable to my global scope. And now I can do print y within the top level, right? The global scope, and I have access to it. If I do not return y, right? If I do not return y, right? It's no longer there. Let's go ahead. Let's remove this. And I try to use print y, I'm going to get an error. It's going to say that y is not defined, right? Because it does not have access to it because it never came out of here, right? It stayed within the local scope of this function, right? Does this make sense? Right on. And it's important to know the interactions between the global scope and the local scope of your functions, because it won't work how you expect to work if stuff is being done within the local scope. And we'll see that right now in this piece of code, right? Here we have a couple variables. We have my number, other number, and operation, right? The numbers are integers. The operation is a string, which is a minus, right? We have a different variable called random number, which is 1,000. And then we're going to print out random number before function runs, right? So this is going to print out something right off the bat. When I run this piece of code, there's going to be a random number that's going to appear here. Then I'm going to define this function. And this function is doing a lot of stuff. It's going to print something out. When we see this line print out, we know that the function is running, right? Because this function, this print statement is only within the function. So if I see this be printed out, that means that the function number process is running. Notice that they define random number inside of here. Well, random number outside is 1,000. Random number in here is 700, right? These are two different things. They then print out a string with the random number they added. And it gets very confusing, so I don't want to go too deep into it. But the main concept of this piece of code is going to show you how we can define variables outside and inside of the function, and the functionality between them is not what you would expect. Right? We then print out the result of num1, which is 5. Operation, which is minus num2, which is 6. So they're doing 5 minus 6 is, and then there's supposed to be a blank here. They define a new variable called num1. So it gets very, very confusing. Let's just see what it does. Right? So, as I showed you earlier, it's going to print out the first line where it says random number before function runs. It does that. Right? It's the first print statement. The random number, it just so happened to be 1,000. Right? That's what they defined it as. So when they printed this out, random number was 1,000. It's not an actual random number, obviously, but they just named it random number. Right? They printed out, it is 1,000 right now. Here's a definition of the function. That's cool. They run the function with the number, which is 5, the other number, which is 6, the operation, which is a minus, and let's see what it does. Well, it ran. How do I know it ran? Well, if you recall from the definition, inside this function, we had a print statement that said inside the function. All right, here's that print statement. So I know I'm currently running this function, and it printed it out. All right, so this is all happening within the function. And notice here at the end of the function definition, they do print function returning. So it's done on purpose so you can see where the function starts and ends. You see when it first starts, the random number inside the function is 700, which is correct, right? They redefined it to 700. The result of 5 minus 6 is, which is this right here, that string with the num1, the operation num2 is. And then they did if-else check. This if-else check is going to check whatever operation was. Well, do you guys recall what it was? It was a minus, the string of minus. So it's checking it. Operation is equal to a plus sign, a minus sign, or division or multiplication. It's going to do one or the other. Well, it's going to only pass this one here because obviously the operation is a minus sign. So it's going to return num1 minus num2. It returns, print this is my number. It returns 3. 5 minus 6 is not. So you might miss something. Am I dumb? Oh, my bad. Num1 is equal to 9. I skipped this part. Inside of the function, they reset the number to a different variable. Num1 is equal to 9, right? Where originally, okay, yeah, originally, that number was 5, right? Num1 being passed as 5. I know it gets very confusing, so I do apologize for this. They changed the number from 9, from 5 to 9, so it now becomes 9 minus 6, therefore returning 3, right? So they were able to change it within here, but notice that afterwards, when they print out the random number, what's up with the number? It's 1,000. Well, didn't we change it in here? Inside the function, we changed to 700. What I told you guys before, what happens if the function stays in the function unless it returns back, right? So afterwards, when we print everything again, the number, the other number, and the random number, notice that they're all still the same number. Nothing changed. The numbers are still 5, 6, and 1,000. Right? 5, 6, and 1,000. They changed inside the function. They did some math. It worked, but the variables never changed. They stayed the same. Right? So whatever happened here stayed in here. It never even touched the my number, the my other number, or the random number. Hopefully that did not confuse everybody. I know it's kind of like all over the place. It just kind of shows you the different levels of the global scope and local scope using different types of integers and change them back and forth. I see here, will the local scope be able to pull the variable of x5 if it's placed after local scope in the global scale? Oh, x equals 5. Are you referring to the tail draw?
Yes, I was referring to that. So for example, in a class I was watching online that if it's up here before the local scope or the function and it shows up later, it won't show up in the function. Is that correct assumption?
I'm trying to understand what you're getting at. Are you saying if we define if this is defined after this is ran, is that what you're saying?
Yes.
Uh,
Would the local scope see the X after it's been, if it's defined later in the program, or does it have to be defined prior to?
if you try to use X inside of the local scope before X is defined, it's not gonna work. You have to define it somewhere.
That answers the
Either-
question. That's what, that's when I'm trying to problem solve some of the questions, trying to find out where some of the things are placed. If they're not placed correctly, then it's gonna, it won't see it. So it's gotta be very linearly produced, correct?
Yeah. So the way Python works, it's from top to bottom, right? So in order of how your code is written from top to bottom is how that works. JavaScript's a little bit different, right? So keep this in mind. JavaScript, the way that it works, it pulls functions to the top of your code. So you can write all your functions at the very bottom of your code and define variables above it, and it'll still work. Even though the function is using variables that were defined above on your code, because when JavaScript runs, it's going to, I forgot the actual term for it, so I do apologize. The way that JavaScript works is that when the JavaScript file runs, it almost reaches to the very bottom of the code and yanks all the functions to the very top, even though they were declared in the bottom. So JavaScript works different. In Python, we don't have that, right? So if your function wants to utilize a variable, the variable needs to be declared either before the function or it has to be declared inside the function. Does that make sense?
That answers my question. That I was watching a JavaScript video, and that's where I got confused.
Yeah, they work a little bit different. So yeah, keep that in mind. Trevor says he's a little confused on how the function pulls my other number into the num2 spot. That's a great question, Trevor. The number processor, look at the definition, my friends. They take two parameters, num1, num2, in operation, right? When they actually call the function, what's being passed into the parameters section? My number, which is 5, my other number, which is 6, and my operation, which is a string, right? So here is what's being passed in to these parameters. Does that answer your question, Trevor? Silence is compliance. I'm going to go ahead and assume that yes. Okay, right on. All right, moving forward. We have a function x equals 5 print. All right, so here we have a function. They define a variable called x, right, and assign it a variable 10, and then they print out the string that says printed inside function, and they add the x in here. When they run my function, it works, right? But then they try to call the x again afterwards. This is within the global scope. This is the local scope, right? X was defined in here, but nothing was returned, right? Notice there's no return statement. They printed it, that's cool, but at no point was this returned anywhere. It's saved into a variable. So when we try to run the print statement on X, it gets an error because it doesn't know what X is. It says it's not defined because it was defined within the local scope, not the global scope, right? If you wanted access to this X, you would have to return X, right? And then save it somewhere, like right here, X variable is equal to my function. And then let's go ahead and do print X variable, right? You have to return it from the function and save it somewhere. And then you can use it, right? If you don't return it and save it somewhere, you can't have access to variables that are being declared within a function because that's the local scope. That is the quick class on functions. Hopefully that answers most of your questions for functions. There's more into it, right? They get more complex. So we will build off on it. Everything moving forward in your exercises will be building functions. So you're gonna get more than enough practice on building functions. smaller to more complex. So we'll talk about it at the end of class, but let's go ahead and finish off here. When to use print statements. This is very helpful, right? Print statements, as I mentioned to you guys at the beginning of day one, are a great way for debugging, right? It lets you visualize your code to understand what it's doing. You want to use print statements often, and you want to run your code often. You do not want to code 50 to 100 lines of code before running it, right? I tend to run my code very, very often, almost like after every 5 or 10 lines, or before every action that I'm doing something to make sure that it's actually working. And a great way to visualize your code is by using the print statements, right? Let's look at this code example for a demonstration. We have this define complex calculation function being declared here. It takes two parameters, x and y. Right, the very first line, they're multiplying x and y and creating a variable called product. They use the print statement to see what the current result is right now. Right. And then before they even move on with the math problem, they printed it out, right? Let's see, is it really printed out my product? Did I multiply this correctly? Although it's simple multiplication, we can probably make the assumption that it's good. With more complex operations, it's not just in math, but like in other stuff, it's very important to be able to visualize, did it do what I intended it for it to do, right? And it's very common to use string interpolation. We did not cover this on Monday because of a lack of time. We'll cover it at the end of class. I forgot to bring it up this morning, or sorry, at the beginning of class. You guys should have continued reading on it, but shoulda, coulda, woulda. I don't want to put it on you guys, so we'll cover this in a little bit. But they're essentially conjoining the string in a variable here. They print it out to get a visual representation of it, and then we move forward with the math, right? Afterwards, we do absolute with the product, then we print it out again. Result after the other step, and then we print the product, right? So we can see, did it work, right? And then we do an if else statement, yada yada, whatever. But notice here, these two quote unquote big operations, we added print statements to ensure that we are getting the intended result. And when we run this, we see here that, okay, well, -2 and 30 when multiplied, it should give me -50. That's simple math. So I tested it out, and I see here it did give me -50. So I know this is good. I can either comment this out or remove it, right? Because I know this is working as intended. I see here result after the other step. Absolute. This method, I believe we covered it, but essentially it converts any number to a positive number regardless its size. So initially product was -60. It just makes it into a positive number. That's what absolute does. We print out the result. It should make it positive, correct? So this did what it should do. So I can remove this if I wanted to. And I can move forward with my code, right? So print statements allow you to visualize your code as you code along and do stuff to ensure that your code isn't going down the wrong path. Does that make sense? I'll cover this in a little bit, Mark. That's a great question. Let me just finish this last one and we'll move to that part. Okay, so the next part is writing your own function. All right, so this is kind of like a try it, right? That's up to you guys. But that's going to cover lesson 2's curriculum, right? Hopefully there's not many questions. I know we went pretty quick on that one, so I'm gonna open up the floor for you guys. Does anybody have any questions on anything that we have covered, right? Anything involving functions, whether it's the booleans, if else statements, let me know. You guys can come off mic or ask in the chat, whatever you guys prefer.
So I know you can't call a method before it's defined, but can you access variables? Say you want to call a method, can you access variables that are established after that call? I'm trying to type it out right now, but I figured I'd try and talk it out.
Access variables after the method is called.
Yeah, so I'm almost there. Just give me
Okay.
one more minute. I'm typing
Okay.
it up right now.
Sure. I'm pretty sure that I think I know where you're getting at.
I'm gonna throw it on the chat right now.
Okay, so we define a print method. Okay.
Or do they both need to be defined before I call that print method with the variable?
I'm a little confused at what this code is doing.
Okay.
Variable is equal to print. So you define a function, right? Is that correct? So you're defining a function. Are you defining a variable afterwards?
Yes.
So, and then you call the function with the variable inside of it. Is that correct?
Yep.
And then what's that fourth line? What are you doing there?
That's me creating the actual variable to use as an argument.
I'm having some issue with this, Keegan. Let's say, can we talk about it after class? Maybe like in a one-on-one, or it doesn't have to be one-on-one, but afterwards we can write some code, see if I can really understand what you're asking.
It was just a question I had on the top of my head. I'm looking it up right now, and hopefully I can get an answer back to you.
Oh, okay. I think I see what you're doing. Okay, so my bad. The indentation was really getting me. So the print of the argument is within the function definition. Is that correct?
Yes.
Okay.
Yes.
And then
I
you
guess I
call.
didn't need to add that extra print around the print method call.
What is var? What is that variable there that you're assigning to it?
That's just a random variable.
Like what? Would it be a string? Because that doesn't, the parentheses is really throwing me off inside of there.
You're right. Let me I'm gonna type it up in my IDE and hopefully it comes out a little cleaner.
Okay, well, regardless, it won't work, right? Because you're doing print method and you're passing in var. So whatever data type var is, it still won't work anyways, because var has not been defined yet.
Okay. Cool. That's the answer I was looking for.
Yeah, it's okay. I'm sorry. My confusion was like I couldn't understand because of the indentation, but that's not your fault. It's just Zoom being Zoom.
That's my bad. I typed that horribly.
It's okay. But that's a good question. Yeah, you want to define this variable before you try to use it because they won't know what you're asking from it.
Got it.
Right on. All right, before we continue on more questions, let me just talk about the F string. What is it doing? Am I still sharing my screen right now?
Yeah, you are.
All right, right on.
It's making our life easy.
We're going to go to interpolated strings. So we saw the conjoining of strings already, right? Using plus signs. There's an actual proper way of joining strings together, right? We call this interpolated strings. For those of you familiar with JavaScript, it looks something very similar to this. We have greeting, and it starts off with backticks, right? It starts off with backticks, right? And this signifies in JavaScript that you're about to create a string that might have variables assigned in it, right? And it would look something like this, hello. And then whenever you're ready to add the variable, you would add the $sign and curly braces, you would say first name, right? So I'm only doing this for you JavaScript folks so you can see how it's done in Python, right? So this is how you would have done it in JavaScript, right? When you want to add a variable into a string in Python, you start with this F keyword. This F keyword stands for formatting, right? This lets Python know that you're about to create a string that's also going to have variables embedded inside of it, right? Here's our two variables. We have first name and last name, Jimmy Fallon, right? These variables hold strings, but nonetheless, they're still variables, right? Here, I am creating a whole new string assigned to this variable called greeting. But I want to be able to dynamically add a first name and last name in here, right? Without having to continuously write a new greeting for every new person. So how can I do that? Well, I can add variables using interpolated strings. I started with the F, and then I open and close quotation marks, right? I write out my string like normal, but whenever I'm ready to find a section where I want to add a variable, I'm going to open up curly braces, and inside these curly braces, I'm going to put in the variable that I want to add here. When I print this out, Python is going to check the string. We can say hello. All right, cool. Everything checks out. And it's going to get here like, oh, there's some curly braces. Hello. What is this? Okay, curly braces. I know that these should be variables. Okay, does this variable exist? Well, yeah, we have first name above. What is first name? It's Jimmy. All right, I'm going to grab Jimmy and I'm going to add it here. Right. And it's going to continue as, as it was before. To get to last name, it's going to do the exact same thing. And it's going to give you a conjoined string with hello, Jimmy Fallon. Now, why is this helpful, Roger? Well, let me show you. What if we had list of names? We have Scott, Keegan, Daniel. Hold on, I gotta sneeze. Sorry for that. We have Scott, Keegan, Daniel, and I see Ahmed. Instead of having to continuously type out a gradient for each one of these people, a little out of scope, but I can show you how it works. I can loop through all these for name and list of names. I'm gonna say print, and I'm gonna start an interpolated string. Hello, name. Right? And I can say hello, Scott, hello, Keegan, hello, Daniel, hello, Ahmed. That just saved me an additional 3 lines of code for every single person that I wanted to greet. Right? I created an interpolated string where I created a default template, and then I'm replacing the variable name for each name that I'm looping through, right? Iterating through this list of names. Right? As I iterate through this list of names, I'm adding it to the string and I'm printing it out. Right? I know it's a little out of scope because this is for loops. We'll get into this later on, but you're able to see how interpolated strings are very helpful. Instead of having to hard code each line for each individual person, I'm able to dynamically replace what's within the string by using variables. Right? Pretty cool.
I have a question.
I haven't answered.
In list of names that you just created, how does for name know that Scott, Keegan, Daniel, Ahmed are names?
Yeah. As I mentioned, it is a little out of scope, so we'll get to it later. But in short, the list of names is, as we already know, it's a list of multiple different strings. This syntax here, it starts a loop, right? I'm gonna say, hey, for each name inside of list of names, I want to do this. This is a parameter, it's a placeholder, very similar to when I defined the function, we created placeholders for what the parameter should be. That's what this is. Does that make sense to you, Michael?
Yeah, so could you name that anything? Like it doesn't
Yeah.
have to say name, it could say whatever. Okay.
Absolutely, I can put X.
But they have to be
Right,
the
for-
same on the top and the bottom.
Yes, correct.
Okay.
It has to be whenever I get in here and I start using X, it needs to know what X is. Well, this is coming from the condition I set up in the for loop, right? Does that
Awesome,
answer your
thanks.
question?
It does.
All right, awesome. Yeah, let's not get too much into it because it is a little out of scope. I just want to show you the powers of having interpolated strings, right? There's some other stuff like escape sequences that are helpful to know, right? So how to create a new line, how to tab, how to add double quotes, stuff like that into your strings. I'll just show you real quickly, right? We're printing out the multi-line. It's a string, but notice that once it gets to the /n, it creates a new line and goes to the next line under, right? And then it adds quotation marks, prints out multi-line, adds another quotation marks. I then go to the next line and then print out string, right? So you're able to use escape sequences like this to do stuff, to format your strings on your screen, right? If this is not the most useful, I rarely have ever really used these. Maybe like once or twice in like my 2 years of doing this. So it's just helpful to know, right? And we talked about the none type, but that should cover everything, right? Going back to Python lesson 2, this is what this example was doing. It was creating an interpolated string with the string intermediate result and then adding the product within here to make a formatted string, right? Does that answer the question in regards to the F string, guys? Awesome. I see the bless in the chat. Thanks, you guys. All right. That's going to conclude, guys, today's official lecture. Right, that's everything that I have for you guys today. We are officially caught up. I believe like 99%, I think. From everything from yesterday's class to today. I apologize if it seemed a little too fast. Yesterday we were not intended to spend an hour on talking about code spaces. But we got a lot more people who did not attend the info session here than we expected. So I wanted to make sure that I covered it multiple times. Hopefully everyone is up to speed and feels comfortable with code spaces for now. And then we also are up to speed now with the curriculum. So we are back on track to our timeline. If it ever feels like I'm rushing, I'm telling you guys, like, I don't have so much time with you guys. Unfortunately, I only have 3 hours to convey all this information to you guys in the most effective manner, right? Which is why also another reason why I tell you guys, like, on your own time, you have to be coding. Like this, it is a lot, unfortunately, right? For those of you who are not doing the immediate cohort that's happening, like, that's closing their registration after this course, that you don't have too much to worry about. But if you are attending or attempting to attend Adventure Platoon, then that's why I tell you, you have to be like coding. Like you kind of have to be doing it because you are in a very tight timeline. It's not impossible, but the odds are against you because coding is one of those things that you have to put miles behind your computer. For those of you who are trying to do courses in the next incoming months, you are right on track right now. For the assignment, it might seem a little confusing, right? This one, the very first one. I always get people like, I didn't know what to do. There's some missing things within here, right? You can already see it. There's a bunch of squiggly lines, right? There's errors in this code. You can see it's incomplete. It says if, and there's nothing else, right? I want you guys to think of this as kind of like the word games that you would get in elementary school, right? You would get a word bank, and then you had a complete synthesis, right, using the word bank, and then you would scratch out the word bank and whatnot. It's something very similar to that. You currently have a variable bank, right? You have multiple variables that you can use. You have booleans, true or false. You have strings, integers. You have a couple of variables that you're not familiar with, so I do apologize for this. I didn't make this part of the assignment, so you might feel a little intimidated with some of the stuff in here. This is a dictionary, and this is a list. The only thing I would say is you'll probably have to use the membership checks for these to check if there's something within here that you can utilize. And I challenge you guys to maybe look into it a little bit if you want to really know more about these. We will be covering them either tomorrow or next week, so don't fret. But yeah, you're gonna use these this variable banks to fill in the blanks, right? Now, what your goal is in this exercise is going to depend on the on this right here, where you have to place the following variables in the correct if, elif, or else statements to trigger the congrats message nested within the conditional statements. Well, let's look at it. Well, it's a lot of different options here, but there is a congrats statement, and as you see, it's right here. So you need to use these variables and fill in the gaps so you can successfully print out congrats, right? So you need to either pass or fail certain conditions up here so that it leads you to this outcome. Does that make sense? Right? Quick example. What can I put here that's going to work, that's going to make me come into this code block right here? Bar one will probably work if true. True is true, right? It's a little confusing, but yeah. If true, do the rest, right? Or I'm sorry, my bad, not if true. If bar one. I was not using the correct stuff. Yeah. If bar one, let's see how this works. And obviously it's not gonna give me what I expected. But notice here that let's actually get rid of it and see what happens when I do it without nothing. I run this and notice that I get an error, invalid syntax at line 11. This isn't a raw Python file, so it's hard to see the line. But it's this right here, the if and the colon. This. I'm getting an error here. So I need to fix it. So if I do if var one and I run this again, what's gonna happen? Well, now I'm getting a different error. The error is here. That means that this worked. It passed. It's trying to run this, but it failed, right? Well, do I want this to pass? Where am I trying to get to? Congrats, right? Where is congrats nested within? Within here, this elif statement. So I probably need to do something that's going to lead me to this outcome, and so on and so forth. Does this make sense to y'all? Awesome. Yeah, it's a little intimidating at first. It looks very confusing. This is your word bank, right? Your variable bank. Use these to your advantage. Try not to repeat them. Some of them you might have to. I think one of these, there's 3 of them, I believe. Oh, there's a, dang, I didn't remember these being so many. You might have to repeat 1 or 2 of them twice, and that's okay. Try to use the other ones to your advantage. There are solutions for all these, if I recall correctly. So don't think like, oh, this is broken. It's just how creative you are with your solution, right? Do not change these. These are not to be changed, right? The word bank stays the same, right? It's not that the code or the word bank is wrong. It's because you're wrong. So don't change these, right? I promise you there's a solution. And just like lesson 1, we have lesson 2 exercises for you guys. Same like yesterday. These look like they're fixed right now. They have the language as expected. But as I showed you guys earlier in the class, you can either do them here or open up a raw Python file that's going to allow you to code along, right? Once again, no one is checking these, so these can be your own notes, so you can do it here or any other platform that you're comfortable with. But that is going to conclude today's class, guys. Thank you very much for your cooperation. And you guys have been absolutely wonderful. I hope to see you guys tomorrow and hopefully keep the same number that we have of students for the remainder of the class. I'm gonna go ahead and stop the recording now. I'm gonna open up the floor for any questions.